Good evening, distinguished ACAN members, gentlemen and lady. You're most welcome to this business evening being hosted by Zone 6, headquarters here in Port Harcourt, Rivers State. We need to apologize that we're starting a little bit behind schedule, 10 minutes behind schedule, but we're going to ramp up everything so that we will be able to finish on time. Without wasting much of your time, I'd like to just welcome to the high table these distinguished personalities. First of all, I'd like to welcome our dear president of ACAN in the person of Engineer Kunle Adebejo, FNSE, FN/T, FN or F-Nice. And so I'd like to welcome him to the high table. Welcome, Mr. President. As the president is taking his seat, we have the privilege and opportunity to have a distinguished engineer, an accomplished engineer, a former local government chairman of Afio local government, Ahafia local government area in Abia State. He is our guest speaker today. He is in the person of Engineer John Ekenjoku MNSE. Please, let's welcome him. Let's give him welcome. We are still expecting the arrival of one of our past presidents, who is resident here in Zone 6, Engineer George Okoroma. When he comes, we'll be on time. I'd like to welcome our dear president, Engineer Kunle Adebejo, for his opening remarks, Mr. President.
Thank you very much indeed. Engineer Moore, and good afternoon stroke evening to all those who are in attendance, and in particular those who are also online. I know that we have the majority online, but I am delighted to just say that I am here live in Port Harcourt. And I think in mentioning to you that I'm here in Port Harcourt, I want to say that since I arrived this morning, early this morning in Port Harcourt, it has been a fantastic time already. This zone has really done well because it's welcomed me. We've gone around, we've done quite a lot up to this time. And now we're in this lovely setting to have this business evening. We are expecting a few more people here in the hall. And of course, we will, in due course, recognize also those who are online. So I won't do any of the recognitions. Instead, I will just welcome everybody to this business evening, second business evening for this year. Congratulations to, and I appreciate Zone 6 for putting this together. Now, just a few words as we start. Firstly, what is this business evening all about? I think it's very important to recognize that consultancy, in fact, I would just say professionals generally in the country are going through quite difficult times. There are a lot of challenges, both in terms of getting work, in terms of executing it, in terms of getting paid, in terms of retaining staff. So there are so many challenges that the consulting engineer is facing in Nigeria, and I dare say worldwide, but certainly here in Nigeria. And one of the best ways of addressing some of these is to have an association like ours, where we share things in common, we work towards improving ourselves, and this business evening is a great opportunity to get together, to listen to an appropriate lecture, but also to come together, rub minds, and see how we can overcome these challenges I talked about. And the reason I'm mentioning this is that when I knew I was going to come down to Port Harcourt, I decided I must continue the latest initiative that we've put in place, which is to visit member firms, sit with them, find out how they're getting on, but more importantly, understanding where the shoe pinches, and see how we as an association of member firms, can come together to improve things. So whilst advocacy and speaking to government is important, but strengthening ourselves, putting ourselves at a level where we can be taken very seriously is also important. So I'm pleased to let you know that today I've visited 3 member firms, wonderful firms, excellent. They're actually firms that I've known the individuals behind it, but I've never seen them in that way. And I want to say that there's a lot that has come out of it. I have notes of things that I think we can start to implement. And that is what Aken should be about. So I'm putting everyone on notice, all the various zones that we will be visiting. But we don't just want to wait for business evenings. So if any of you are desirous of visits, other than me making that invitation, please let us know. And we'll very much be pleased to come in, sit with you. Maybe the only thing I'll say is today, in one of the member firms, the principal called out some of his staff and said, come on, this Aken you have been hearing, this is now Aken here, the president. And it meant something to the staff because they run out and say, okay, thank God. Maybe they've been wondering whether their subscription has been going to, I don't know. So it's a wonderful thing. And I'm particularly pleased that this evening we have a good lecture set up. So please enjoy it. And let's realize that this is the beginning of making a lot of impact in the fortunes and overcoming challenges of our member firms. So I welcome you all to this second business evening for this year. Thank you very much.
A round of applause for our dear president. Thank you, Engineer John Ekenjoku, our dear president. Thank you for gracing this occasion, coming all the way from Lagos to encourage us here in Zone 6. Going forward, I'd like to recognize those who are already tuned online watching. We recognize Cynthia Akinola. We recognize Ale Olayenka, Engineer Eddie Atumoyogo, Engineer Adebowale Adepoju, Engineer Bole Oyowe, Engineer Okechukwu Ugu, FNSE, Engineer Olufemi Kaderi, our dear Managing Director. We equally recognize Engineer Akin Wole, Engineer Akara, Engineer Ajebade Oke, our immediate past president, and Engineer Garba Ahmed. Let's just give a clap for those who are watching online, who are tuned online. So as we proceed, we will be recognizing those who are joining online. Meanwhile, I like at this time, before the guest speaker comes on his lecture, we need to talk a little bit, introduce the guest speaker so that we will be able to know the man, Engineer Ekenjoku MNSE. He is an accomplished electrical engineer, a Korean registered engineer. He has attended several trainings. He has worked with National Electric Power Authority, NEPA, where he held several senior positions. Engineer Ekenjoku has also worked with the Shell Petroleum Development Company, SPDC. Engineer Ekenjoku was the executive chairman of Ohafia local government area in Abia State from 2016 to 2018. Engineer Ekenjoku was a senior special assistant to the governor of Abia State from 2019 to 2020. Engineer Ekenjoku MNSE is currently the technical director of Jonek Nigeria Limited. Let's welcome our guest speaker tonight, Engineer John Ekenjoku. Let's put our hands together for him, please. Having said that, Engineer Ekenjoku will be talking to us in his presentation, Fire Protection Engineering in Buildings and Industrial Facilities in Nigeria, the Planning, Design, and Control. Welcome, sir.
Mr. President, Engineer Kunle Adebajo, Fellow Nigerian Society of Engineers. Engineer Otunte Otuene, the coordinator, Zone 6. And everyone for us that has come to attend this business evening. I want to say thank you for coming. Thank you, Mr. President, for the opportunity. Yes, we'll be discussing fire protection engineering in buildings and industrial facilities in Nigeria, planning, design, and control. Yes. By way of introduction, engineering design and practice that is aimed at minimizing the effect of fire and assisting in preventing damage to life and property is here referred as fire protection engineering. In Nigeria and in the UK, it is referred as fire protection engineering. But in the US, what you get is fire safety engineering. Fire can occur anytime and within a short time spread to a dangerous level with attendant damages. So there are significant benefits in investing in fire protection engineering, especially when the system functions as expected. Prevailing fire protection systems are salient safety guards inside modern buildings and industrial facilities. You rarely notice them except when needed. They can make a whole lot of difference between a minor incident and a life-threatening disaster. Fire protection systems can be installed, one, in private homes, secondly, in commercial buildings, thirdly, in public buildings and industrial facilities. They are designed to, one, detect danger and alert occupants early enough. Two, to control fire spread or growth. They are designed to support evacuation of occupants and so help to reduce damage to buildings, industries, expensive equipment, documents, and inventories in the event of fire outbreak. You have to follow me using your phone at the same time. Fire protection engineer can be categorized into two main types. You have the active fire protection systems and the passive fire protection system. Active fire protection system reacts in times of fire outbreak, while passive fire protection system, they are non-reactive by contrast. Rather, it refers to the use of or incorporation of non-flammable materials during construction by the architects and engineers. You also have non-electric fire protection system. This one does not need electricity to function. So in the event of power failure, the system will still operate or work if fire occurs. Yes? We have three main types of active fire system, fire protection system. You have the fire alarm system, and fire alarm system functions this way. It is designed to detect smoke, heat, or flame, provide early warning by way of alarm. There are components that make up the fire alarm system. You have smoke and heat detectors, fire alarm control panels, an example you can see there, manual pull stations, horns and strobes, and emergency lighting and backup power system. So that's the component that make up the fire alarm system. Okay, next slide, please. The function includes, one, to monitor, two, to trigger alarm, and number three, to initiate automated safety response. Latest fire protection engineering systems are in some cases integrated with emergency lighting system, HVAC shutdown system, elevator systems, smoke control dampers, and sprinkler systems. Know that early detection and consequent alarm is key to saving lives. This is because occupants need time to escape. Next slide, please. You have the second one, that's the fire sprinkler systems. In this system, when heat from the fire activates the sprinkler head, water is automatically released over the fire. The principle of operation is that heat increases to a limit or ceiling, and the thermal head melts and breaks, and then water is released directly over the fire. Know that it is the sprinkler head only that operates when exposed to heat, and not the entire system. This is one of the most effective systems It controls the fire before it spreads beyond its origin. And the third one is the fire suppression system. In this system, environmental factors are considered. Specialized fire suppression agents are used where the use of water is not the best option. For example, you use clean agents where you, in data centers, you use gas-based agents for archives and electrical panels, and use wet chemical agents in commercial buildings or commercial kitchens, and then foam agents in industries. This system is designed for rapid response suppression of fire while minimizing damage to equipment. The system is very useful in server rooms, industrial facilities, equipment rooms, and hazardous environments. Passive fire protection engineering system do not activate, rather they contain fire. That's the difference. This system is built into the structure right from planning, design, and construction. And of course, we are going to be talking about planning, design, and construction later. Types of passive fire protection systems are fire doors, firewalls, fire escape routes, and of course, fire stop sealants. Okay, thank you. This system slows down the spread of smoke and flames and limits the fire to its origin, making evacuation and emergency response time possible. Next slide. Now let's look at the principles of fire protection engineering. The principle demands understanding of the functions of the different components and purpose of fire protection systems. These systems work differently, but all have common goal. And that common goal is, one, to detect smoke, heat, or flame, alert occupants, control and spread of fire, then make evacuation possible and easy, reduce damage to life, structures, and valuables. Functions of all components, both active and passive, are combined into a coordinated safety network to ensure optimal operation. No single component or device gives full protection. And that is why step-by-step strategies are adopted. Next slide, please. Let's look at the economics of fire protection engineering. Every business venture, huge businesses and financial investments are involved in constructing buildings and industry. In some cases, mortgage loans are taken from mortgage banks, industrial loans from Bank of Industry, export-import loans from Afrexim Bank, development loans from African Development Bank and Development Bank of Nigeria. And when you secure them, they are usually with interest, running with time. And the purpose is to finance manufacturing equipment, information technology hardware, infrastructure, electrical power facility, document and inventory. If these investments are subjected to fire outbreak for a significant time, next slide, certainly it will lead to financial losses as a result of fire. Fire damages, the thing that will result when it comes to fire is that there will be damages as a result of the fire outbreak. There will be company downtime. And after that, you will need to reconstruct some of the facilities. You need to replace all the valuable that have been lost to fire. And then there will be a loss of contracts and markets. For instance, God forbid that this place, something should happen. The customers that come in here will not be able to come. At that very little time, you are losing revenue. Installation of fire protection systems in buildings and industrial facilities have several economic advantages. Number one, they save lives. They help in saving lives. They save money. They safeguard properties and investments. They reduce downtime, safeguard irreplaceable assets, and lower insurance costs. They also help to adhere to rules and regulations. And they react to fire faster than the public fire service. Next slide. Let's look at the engineering of fire protection systems. The choice of fire protection systems depends on some factors, namely, your best option, that's what you desire, the kind of facility, the possible risk inherent, the building so construction codes, building and construction codes and regulations. That all concerned when activated. What is the maintenance requirements? What is the maintenance schedule? What are the inspections and tests required? Systems require regular inspection, test, and maintenance. Yes, just like this. However, this depends on the system type and local regulations. While comprehensive fire protection systems play important roles in keeping inhabitants, assets, and infrastructures safe, faster than the public fire service, scheduled regular inspection, test, and maintenance is recommended to ensure compliance and operational readiness. Let's look at fire protection and prevention. Fire protection and prevention principles rely on a combined strategy, of proactively eliminating fire hazards, fuel, heat, and oxygen, early detection and warning, active suppression of fire. This system work together to reduce the risk of fire erupting. Fire protection strategies include 1, controlling ignition. Number 2, eliminating source of ignition, enforcing no smoking policy, use of permit for hot work, welding, and spark producing activities. Number 2, maintaining electrical safety. And these are the things you need to do to maintain electrical safety. Avoiding overloading of electrical circuits, regular inspection of electrical installation, heating, and cooking facilities. Some of this fire you see in high-rising buildings as a result of electrical problems. Otherwise, why would it be that in the night, midnight, you see a building erupting in fire? From where? From electrical systems. Proper management of flammables. That's number 3. How do you do that? Safe storing of combustibles, chemicals, gas cylinders in approved, well-ventilated containers away from heat. And number 4, housekeeping. Houses, kitchens, and industries should be kept clean and dry. Escape routes, staircases, exit doors should be kept free of hindrances or obstruction. Now, we ask ourselves, why the need? Nigeria is still a developing nation, and so there is the need of improving our policies and laws to guarantee improvements in the social welfare and social protection of lives and properties. This has become more necessary in the face of incessant fire outbreaks and its attendant losses. Every building and industrial facility should be encouraged to incorporate fire protection systems to reduce the risk of fire across the nation and the losses that follow. This, of course, will complement the work of public fire service in the same way that private boreholes complement public water supply, private generators and solar systems complement public power grid supply, and GSM system has complemented NITEL and enhanced communication in this nation. Now, let's talk about the planning of fire protection engineering. There are 3 factors you need to do when you are planning fire protection system. Number 1 is to think about prevention. Number 2, you plan active and passive structural fire protection. Number 3, you plan for emergency response preparedness. You make provision for that in order to minimize risks to life and property. For better effectiveness, the planning will need to be detailed and comprehensive. This will include information on how to control fuel hazards, building systems identification, clear and actionable procedure for evacuation, not evaluation, evacuation of occupants according to needs. There are key factors that must be in the plan. 1, fire prevention plan must be documented. This plan identifies potential ignition sources, flammable and combustible fuel hazards, safe handling of hazardous materials, schedules for waste disposal and management, systems and equipment maintenance schedule. Number 2, active fire protection plan. This plan must provide for active detection and urgent warning, active suppression of fire through sprinkler systems and fire extinguisher. Number 3, passive fire protection plan. This includes incorporation of structural features to contain fire and so prevent or limit damage to structures through the use of fire doors, fire walls, fire stop sealants, and provision of escape routes. Number 4, emergency response and evacuation plan must be there. This plan speaks to designate escape routes. It is required that for every room, there should be 2 escape routes. That is what the regulation says. And there must be exterior muster points where if something happens, people can gather, run to that place for safety. And secondly, you must specify the roles and responsibilities by assigning duties to fire wardens and fire marshals to ensure 1, head counts, assist those needing help, then direct first responders to safety. And the last one there, outlining standard response protocols. This is done through the use of what we call RACE, meaning rescue, alarm, confining doors, evacuate occupants where a fire is detected. Now, let's look at the documents itself. In the plan, you document it. For you to be able to create customized protection or safety plan for any company or any client, Regulatory bodies and local fire authorities require that the underlisted document must be documented. Number one, job designation and names of personnel responsible for system operation and maintenance. Number two, floor plan identification, exit doors and routes, utility shut-off points, and fire extinguisher locations or stations. Number three, periodic training and evacuation drills schedule. These are the things that they will want to look at before they approve. Customized protection plan. They are guided by one, the type of structure. Is it a home, domestic home? Is it workplace? Is it commercial? Is it industrial or construction sites? Then they want to see what is the number of floors and what is the dimension. That's approximate square footage. Next slide, please. Now let's look at fire protection design and control. Fire protection design process follows the development of a safety strategy called fire protection plan document. This strategy seeks to meet the following requirements. One, deemed to satisfy. Two, performance solutions. This can be achieved by referencing or adhering to FEB, what we call Fire Engineering Brief, and FER, Fire Engineering Reports, or local codes and regulations. Next slide, please. Effective fire protection design. A performance-based design allows you to achieve the following: desired function, aesthetic value, other alternatives to deem to satisfy. This approach enables the building designer to create a more exciting and beautiful design that enhances occupation and reduces costs. Next slide, please. Now let's look at the benefits of effective design. Yes. Much is achieved when the system design is effective. And those benefits are: one, compliance to codes and regulations. Two, cost-effective design, meeting project goals, greater flexibility or scope in the design, and the use of building. Number five, timely delivery of projects, practical inspection and maintenance requirements. Okay, next slide, please. The engineering design has a process. That process must meet the following requirements. Number one, local codes and regulations. Approval of protection plan or strategy by the authorities. Engagement with fire protection engineer at the early stage of the building design in order to accomplish design solutions. Therefore, the engineer's approach will be: one, to develop most effective solution. Two, engage stakeholders in that process for feedback. Consult the authorities and feedback. Number four, comprehensively review the building form, materials used and occupancy. Now, every stakeholder has a function. Let's look at the table there. First of all, the first person there is the protection engineer, and the responsibility will be to produce that plan document, that report, and that document. And that document must contain, number one, safety measures, completion requirements, building management plan, inspection and maintenance requirements. Then let's look at the building architect or estate surveyor. Two of them must agree. The agreed work must comply with the authorities' codes and regulations. And then project designer, the building architect is different from the project designer. He must collaborate with other consultants, incorporate the safety measures into the design. And then the project owner, his responsibility is to ensure provision of documentation, project maintenance plan, while the project manager coordinates all the activities both the consultants, the owner, and all those consultants must be people who understand fire-related responsibilities, engineers who must execute according to plan. Now let's look at design and control. Design and control of fire protection entails integrating active and passive fire protection systems in compliance with national and international standards. This is regulated by statutory bodies like here in Nigeria, we have the Federal Fire Service, which oversees national fire safety enforcement. At the state level, we have the State Fire and Rescue Service. For instance, in Lagos, that's what it's called. They enforce it at the state level. Then you have Nigeria Fire Extinguisher Control, NFEC. This agency tracks portable fire extinguishers across the country, aimed at reducing substandard equipment and to ensure compliance with safety standards. Now let's look at the standards. Yes, I'm right there. Building designs are regulated by international standards and codes. For instance, you have the NFPA, National Fire Protection Association. You have the ISO, International Standard Organization. You have the BS, British Standards, EN, European Standards. And then locally, we have the National Building Codes of Nigeria. And then you have the State Urban Renewal and Regional Planning Laws. Design and construction of buildings and industries in Nigeria are controlled by statutory regulations from statutory bodies like the NBC and the State Urban Ministry of Physical Planning and Development. That's where urban renewal departments are located. This is necessary to ensure that structural designs, fire protection, professional accountability, environmental sustainability meet standards and hence help to prevent or minimize building collapse or damage. We have mandatory approval process. There are processes that you must follow. To legally commence any construction or development, a step-by-step permit process must be followed. Number one, sites and sites. Okay, good. Site and site layout approval. There are two things there. One is the site. The other one is the site layout. You must obtain approval before development. This is to ensure that the land to be developed is properly zoned. Like under urban renewal, you have an area that's designated for residential, for commercial, for industrial, and government area. Next slide, please. Now, number two is you must obtain development permit after the first one. And this entails submission of working drawings, which includes architectural, structural, electrical, and fire protection details, duly signed by registered professionals, recognized by the planning authority. Number three, site inspections. To ensure timely alignment and compliance with approved drawings and safety codes, the local urban renewal and regional authorities. What's happening? They undertake periodic regulatory inspection or checks during construction. So they keep visiting the site. Number four is the certificate of habitation. This is the final inspection by the code enforcement officer to verify that structural safety, sanitation, and accessibility requirements are met before occupancy. Now, you have the requirements for site safety standards. To ensure that site standards and safety are assured, it is required that the following are observed. Number one, professional accountability. This entails that chartered professionals prepare and execute the designs, e.g., CORAIN for engineers, ARCON for architects. Number two requirement is that soil and structural integrity, you must consider. How do you do it? You conduct a test, soil test, or subsoil investigation. This one is required when you are going to build a multi-level building. Any building has more than 2 floors. Then structures on low-bearing soils. Number 3 is you consider the densities and setbacks. What do you mean here? In order to prevent overcrowding and flooding, it is required that building permissible heights. There are areas that the height of buildings should be limited based on the soil. So you look at the permissible heights, you look at the plot coverage, public safety, and required space. The must be strictly according to regulations. Number 4, environmental health. Industrial projects require EIA, Environmental Impact Assessment clearance. Site pollution, waste disposal, and management are controlled by additional regulations by NESRA. NESRA is National Environmental Standards and Regulation Enforcement Agency, NESRA. So, fire does not fear anybody. No matter how beautiful, how expensive the building is, how well decorated, fire does not respect anybody. If you are not careful, if you don't take the safety measures, fire can occur. And anytime it occurs, look at what happened in Lagos last time. People were trying to escape from up there. Some of them fell and died. We lost so many persons. Now, if there was a proper escape route, if there was an alarm system that informed them immediately that smoke, when it had not become fire, just detecting smoke and alarm is sent, people would have started running out. But maybe there was no fire alarm system that alerted people there is fire danger for people to start. At least you need up to 5 minutes, 2 or 3 minutes to run away. And it caught some of them and they died. So Nigeria should grow to the level where it will become a law that public buildings, government buildings, commercial buildings, even churches, everywhere, if private homes, these days people build out, they don't consider that fire can occur. And it can happen anywhere. Gas cylinder can blow and fire. So fire is something that can happen anytime. And the way we are going is where there should be a policy that when people are building, while designing, as we do civil design, structural design, electrical design, fire protection design should be part of the building. So that we install it in our homes, in our business places, for our safety. Because if something happens, you will lose so much money. You go downtime, so many things. Markets and customers will go. It's our prayer that fire will not come. But we have to prepare for any eventuality. Thank you so much.
A big hand for our presenter, our guest, Engineer John Ekenjoku. Right. Just we want to recognize the chairman of OMOC branch of the Nigerian Society of Engineers, Engineer Nari. You're welcome. We equally want to recognize the presence of the chairman of the Port Harcourt MNSE here, Engineer Belema Ikena. I'll be crucified if I fail to recognize the presence of our first zonal coordinator, Zone 6, in the person of Engineer Tony Nwobo. And the man who brought us here, Engineer Otuene, who is our zonal coordinator. He's been doing the yeoman's job today. Okay, now we have opportunity to ask questions. So we're going to be taking the questions, maybe 3 in a row so that the guest speaker will have to answer. So you can signify by raising up your hands, so I will bring the microphone to you. And being aware that there are people, online who are equally watching, who would want to, ask one or two questions or make some contributions. So if they raise their hands online, please, would you just be able to tell us? Okay, who wants to go the first shot? All right, Engineer Belema, please.
The firefighting, most of the residential fires that we've observed, they are gas related, gas explosion indication. And when we look at the hydrant, the firefighting equipment in the residential area, I don't think that education has gone enough, because we are always with the traditional pattern of pouring water. And when it is gas or oil in the pot, how easy can we pass the information on how to fight these fires? Thank you.
Okay, that's the first question. I don't know who wants to go. Any other question? All right, Engineer Wobo.
Yeah, thank you, my president and members of ACEN and our honorable visitors. My own is kind of commendation. It's a really quite expository lecture. We are ACEN, Association of Consulting Engineers, and consulting, we do planning, design, and management of projects. And incorporating something like fire protection, if I say, I'm trying to indict anybody or indict our association, but because we're kind of organized body, we have unorganized body of practitioners who are equally into consulting, which involve planning, design, and management. And you discover that in most planning, we don't incorporate safety, fire. We only think of getting the soil test, especially in buildings, getting the soil test, getting the structure, getting the aesthetic, the architectural side and everything. And we don't incorporate even the electrical aspect most times. It always come like afterthought, after everything has been planned during execution. Now, oh, we didn't put this, we didn't do that. Will become fire protection plan becomes emergency. So, giving us this lecture this time is a quite commendable to our planners, because most times we hear about design, planning, everything. But here, one of the things that really matter in buildings, even in the society, which can cause, if a fire incident in a twinkle of an eye can render somebody useless or even cause of life. So, but you are here talking about it, expanding our knowledge, understanding, exciting us that these are the things that while planning, from the planning stage to design and management, we have to incorporate it. So I want to thank the planners. I want to thank the lecturer for bringing this topic. It's quite happy. Thank you very much. Our MC. Thank you very much.
Thank you, Engineer Robo. All right, you signify something. Ignatius, yes.
Good evening, President Aken. Good evening, members of Aken. Thank you very much for that wonderful presentation. In your second to the last slide, you stated that soil investigation is necessary when you have more than 2 floors. Are you making reference to any standard or code? Thank you very much.
Well, I think we already have 3 questions, so we ask the guest speaker to answer. Yeah, the next batch will come. We are taking 3. Now, as we are asking the questions, our past president, the current president of FIDIC Africa, and the person of Engineer John Ekenjoku MNSE walked in. You're welcome, my president. Welcome, Mr. President.
Okay, the first question was on gas-related fire protection system. Where should you have oil or gas? Yes. The kind of system that is used where you have gas or oil. I remember I said fire suppression system. Suppression system is what is used, and it depends on it works based on the environment, where you can easily have oil, something that is slippery. The kind of fire protection system needed there is fire suppression system. There you can use foam, some use clean agents, some you use gas-related, gas-operated suppression system. Depends on what you have. The design is based on the environment where you'll be using the fire protection system. So for oil companies, different types are used. If it's in the offices or private homes, what you like, you work. Thank you. Then the second question was mentioning 2 floors where you have soil investigation has to do where do you have more than 2 floors. Yes, that's what the regulation said. I was telling you about regulation, that what governs in the plan. Once the floor is more than 2, you need to do a soil test. 2 floors. Once it's more than 2 floors, that's what the regulation says. But oftentimes you see people go to 3 or 4 without even doing any soil test. This place is hard. It's good. It's good. They work on assumption. But engineers, professionals, we don't work on assumption. You work based on rules and regulations. So you follow. When you want to design, when you want to do whatever, you look at what does the regulation say? What does the code say about where to work? I don't know if I have answered that question. Thank you.
Thank you, Mr. Guest Speaker. We have our immediate past president online. He wants to ask his question in the person of Engineer Ajibade Oke. Yes, online, please.
Can I unmute myself? Yeah, let me first of all say I congratulate Zone 6, as usual, for doing a good job. And my president, I'm sorry, I missed the protocol. My president, and of course, after the president, is the president of FIDIC Africa. I recognize all of you, my coordinator, present and past. Now, the guest speaker has done a good job. And I must say, I am always very interested in fire prevention, fire protection, and then firefighting. And he's touched all of them. Now, my problem is when you look at virtually every building, especially 3 floors and above, they don't have enough fire awareness information. I believe that once we are going beyond 3 floors, there should be the wet riser and the dry riser. The dry riser will be where, of course, the public firefighting, something we plug into, and it go to everywhere. But buildings in this country don't take care of those requirements. Now, from the way the guest speaker has spoken, it looks like he knows enough about what is going on in government. I'm asking, can he please put it in standard code that once we have a building that's more than 3 floors, there should be 2 rising pipes, 1 dry riser, the other one wet riser, and there must be a standard firefighting pump and equipment installed. Thank you, my president.
You want to respond? Yeah, I appreciate your question. I'm Engineer Dennis Dania, mechanical engineer. That is part of my field. Yeah, in the area of dry risers and wet risers, actually, like the speaker said, we mostly use dry risers when it's going to more than 3, 4 floors. And the landing valves has to be well installed. Then the challenge of that is that when you said wet risers, I think mostly we use wet risers for ground, for perimeter installations. And it also borders on heavy tanks, fire tanks, all over the place. And that fire tanks also have to have pumps. But for the dry risers, it's mostly required when the floors are more than 3 or 4. So dry risers are mostly required when it's more than 4 floors or so. And so such a case that you may need a fire tank to come and hook onto landing valves. There are landing valves that take it up from there. And then each floor must have its own landing valves for operations. And in that case, you must have hose reel brackets that will be well installed. And of course, there will be kind of proper orientation. But it also goes with fire hose reels. The dry risers go with fire hose reels. For minor fire, you use fire hose reels, which must be on each floor. But for a major firefighting, that is where, because of the height of the building and also the volume of water required, there has to be a landing valve. A landing valve at the ground floor, that is takeoff valve. And then another floor. So the firefighters must go with that hose to that floor and hook onto that dry riser valve, that is landing valve on that floor. And then the water tank has to pump the water at a pressure required for the other valve to open, and then they have to fight the fire as if they are fighting the fire on the ground floor. That is the design of dry risers. But in most cases, dry risers and hose reel must go together when you're doing some designs. You must have hose reel. And in most cases, because of our peculiar environment, Nigerian environment, we try to make sure that hose reels use gravitational force. In other words, the tank, the head available for the water, for this must be very much available. And of course, if that building has a water tank, that's overhead tank. The overhead tank serves also as a residual deposit for the hose reel. And so when you are piping, doing your plumbing piping, you must make sure that the last part of the tank is for the hose reel.
And then the other part is for the plumbing system. So that at any point in time, there's a residual water available for the fire hose tree. Even the whole secretariat, the whole place has no water, there is water reserved for the fire hose tree at any point in time. Those are the design parameters. And that's my little response. Thank you, sir.
Thank you, Engineer Dennis. Yes, he has the knowledge. Okay, I think he has not just answered that question, but I just want to add that there's a little difference between firefighting and the fire protection. Fire prevention and protect. As I dealt with fire prevention and fire protection, I did not deal with firefighting. Firefighting is what is done by the public fire service, the government. When there is issue, you inform them, they start getting their vehicle, running to that place. By the time they come, maybe the fire has already done, damage has been done. And sometimes the vehicle may not be ready for operation. There may be faults. So that's why we said fire protection system is something we need to imbibe the culture here in Nigeria. Because you build it into the house or into the facility. You don't wait until fire service come. If you have to wait for fire service to come, damage would have been done. So that is the difference. So the public fire service, we cannot depend on that wholly. The fire protection system is to minimize the effect first, while you invite fire service for when it has become uncontrollable. But the fire protection helps to limit it so that it does not damage your facility. So that's the difference. Thank you.
All right, Engineer Jerome.
Okay, I'm Engineer Jerome Peters. I want to, first of all, let me thank the presenter for a job well done. And I want to look at it from regulatory point of view, because in this part of the world, we talk more and do less. And I will be looking at it in a manner that we can drive this idea, because if we are all working to ensure that this training, this knowledge is passed to authorities, I bet you the incident of fire will be well contained in the system. Because if you look at it, anywhere you go in the civilized world, you see even in one room, before you are given okay, if you are a property owner, before you give out your house, some authorities will approve that this house is fit for purpose for habitation. And one of the requirements is fire system, that system, sewage system, electrical compliance. All this will be checked before that one room, self-con, like in Denmark, self-con, before you can move in. You will get clearance from these bodies, including fire system, meaning that the inspector will come to your house to be sure that that house is fit for purpose before you are permitted to rent it out to somebody. So you can see the circle of controls to ensure that people are safe. Now, in our country, the good thing is that we have a law. If you look at our building codes and all the system, you'll be surprised that fire codes are there. These measures are there, but nobody talks about them. If we drive this idea, helping government to enforce it, by the time you send a building plan, even if you are building 2 rooms, there must be a minimum fire protection into that 2 rooms. If we enshrine it, drive the system where government will not take it as part of requirement for building approvals, it means that we'll be achieving it. At least it will be a milestone for the interest in fire prevention. Otherwise, we talk now, nobody cares. Apart from the industry, the oil and gas, where fire prevention and planning is very critical and serious, or the industrial system like high-rise building. Okay, let me give you an instance. In a country, if you are buying a property here, and you have small buildings around you, and you want to build a high-rising property that requires serious fire engineering, it will require of you to protect your own and protect your surrounding. The code gives you, because they feel that if you provide fire system for your building and the next neighbor do not have it, they're endangering your assets. So you see what they do. If they see that you must take that location, you have to provide a protection plan for your own and those surrounding you. That is the only way you can secure your own. Because you can't live in a neighborhood. You have fire, you have firefighting, you have everything. The man in the back near you have no fire system. He will burn his house and burn your own. So you see, that is the kind of system so what I'm saying in summary is, how do we drive this system to government? Let it be practically entrenched in the building approval code for even small, because all we are saying here, we are looking at high-rise building. No, it must start from the basic infrastructure as long as building is concerned. Thank you.
Thank you, sir.
Good evening, all. My name is Engineer Ekenjoku MNSE. Okay, so my question is to the presenter. Thank you very much for the presentation. But your presentation was mainly on the building, that's maybe residential, private, or commercial buildings, so or industrial. So I just want a little bit deviation from, because of this fire incident, because where I worked, we had a situation. So does this fire protection stuff, does it cover temporary facilities too? Temporary facilities, I mean, for example, if you're in a location, the building, not the kind of accommodations there are all these porta caves and whatever. So we had something of a lighting poles. So we had a fire incident on a lighting pole. So, but there were we had a fire alarm system in place, in the sense that all the porta cabins, they all have the smoke detectors, fire alarms. But we noticed the street lights, there were no signal that could trigger when the fire actually broke out. So it was a passerby that saw it, the now raised alarm, fire, then immediately they activated the alarm, everybody came out. So now, this fire prevention and protection, is it that is only applicable to the more concrete structure, or is not applicable to a temporary facility? Thank you.
Thank you. Fire protection systems can also be applied to temporary installations. For instance, construction sites. Construction sites are usually temporary. Even office building like Julius Berger, if they get a contract and they have a site here, after using it, they can move to another place. I was involved in when Daewoo Engineering was building the APAM 6 power station for Shell. And first of all, there was temporary offices and accommodation for the Koreans. So the office that Shell used, temporary office, and the one they will use. We installed fire protection system in there, temporary offices. And when they finished building the power station, they demolished the temporary accommodation and took away whatever they needed there. You understand? So you can install it wherever you occupy, because it's for your safety. It's for your safety. Somebody can die in a temporary accommodation or temporary sites. Wherever fire can occur, you install it. The only thing that they hear in this country, because of our economy, we're always trying to, cut corners. But oil industry, they enforce standards because they have the money to pay for it. Thank you.
Okay, we'll take your question. We want to take, first of all, from Nimot Movili online. Mwili, okay, Mwili, okay. Neighbor Mwili.
Yes, thank you. Thank you very much, sir, and good evening, President. My name is Engineer Nimot Muila. I'm the chairman of the Nigerian Society of Engineers, the Keja branch, and I work for Arab. So my question is a question and a recommendation. I think we kind of sometimes dealt so much on code and standard without the enabling environment to make the code and standard work. And that in respect to the firefighting that we're talking about, sometimes we have constraint of accessibility to fight the fire. So a facility will have made provision for the fire, for firefighting facility, like making fire hoses, the risers we've been talking about. But in terms of accessibility of equipment to fight the fire, we don't usually consider that in the planning and in the design of our buildings and infrastructure. So it renders the firefighting equipment and strategy that have been made in the building, it renders them ineffective. So I think that should be part of the recommendation that should put forward. Then at times, the public facility that is even available, sometimes they don't have water, sometimes they don't have ladders. So I think part of our recommendation that we should put forward should include the accessibility, availability, not just for the individual building, but on a city scale level, so that it's really effective. I like the example that has been mentioned on, I think the example of the DEWU and the role of JB. We all know what JB can sometimes be of support to in fire because the public infrastructure might not be available. So I think in really making firefighting effective, we should also put into consideration the accessibility. Then across various cities, I know for Lagos State, we have the Lagos State Safety Commission. We should also list those commission or those bodies that support various states at various levels. Thank you. That's my maybe questions and recommendation. Thank you very much, sir.
All right. Yeah, okay. At this time, I think we are done with the questions. So, yeah, no, it's a contribution. So, the next thing we're going to do right now is to call on our president, Engineer Kunle Adebayo, to be able to appreciate the guest speaker and maybe make a presentation to him. Mr. President.
Thank you very much, Engineer Moore. And thank you everyone for very lively discussion. I must thank the speaker. But before I do that, I think I should just make a few of my own comments or questions. I think my major comment still revolves around how we do things in the country now, which I think needs to be taken up a notch. Not just the speaker, but all the other discussion, we kept talking about fire protection as if it is a defined entity. You either have or you don't have. And I think as I sat here, I was wondering why is it only in Nigeria we don't talk about fire rating in terms of 60 minutes, 1 hour, 2 hour fire rating, etc. I didn't hear much of that this evening. And I think that that is very important because it's not, fires will occur. As the lecturer has quite rightly said, what happens when that fire occurs? And even the last speaker too, Engineer Muili, also has alluded to the fact that we need to make provisions to fight the fire so that we limit the issues. And I know the speaker said so. So I would have loved a situation where we talk about how we get, for instance, a warehouse. It shouldn't collapse immediately the fire starts. There must be enough time for the occupants to evacuate before it starts to face the effects of the fire, as it surely will. So I would like a situation where our codes and our discussions are talking about what do we do to protect the steel. Steel will always, for instance, it will always react to fire. But if you can protect it and keep it away from reaching those temperatures, or concrete, then you're actually giving the fire protection. And that's what we as engineers need to design. We can't sit and just say, we hope there will be no fire, or if there's fire, but we need to design it and give. So I'm still going to maybe say that in part 2. I'll ask the, or after the session when we're having a general discussion, just to say that I think we should be considering that. The other few points I noted, we talked about the codes here, and I believe, and I stand to be corrected. I don't think we have really sound fire codes in the country. Because even the presenter, when he presented, he just mentioned that there is NBC, that's the National Building Code. And thank God his recommendation was that that's not enough. We need to be much more specific regarding fire. So I think it's very important that we take away from here today the need to do a lot more. And as engineers, we don't do things in half measures. It has to be done thoroughly. So just like I'm just seeing now, as I look at the screen, I'm seeing that they have massacred my name. they put Y there ahead. The operator has, you know, when we were in school, when we used to go, in those days, you went to watch film. Those, particularly in Ibadan, we used to go to Scala, and you go to the film. And as the film is starting to misperform, everybody starts shouting, operator! Because the operator is at the back there. So he will quickly wake up and put the film back on. So I think that's what's happened here. But can I please ask the guest speaker to come to the front? Engineer John Ekenjoku MNSE. We can't thank you enough for coming here as guest speaker on this second business evening, which, as you can see, the room is full. So this is just a token. I think the real appreciation I'm going to ask for now is a big round of applause, please. And I'm sure those who are online are also giving you their own applause. But this is a token from Aken. It will allow you to put this on your mantelpiece and show that you've done real justice to this by not only heeding to our invitation, but dealing with the topic fully. Thank you very much indeed, and God bless.
All right, so I'd like to invite our honorable coordinator, Engineer Otunde Otuene, for his.
Thank you, sir. Sir, you can't leave. Yeah. Okay. Mr. President, sir, thank you for giving Zone 6 the opportunity to host the second business evening, and welcome to Port Harcourt. So the guest speaker for today, Engineer John Eke, thank you for a wonderful lecture. I want to thank each and every one of us for finding out time to attend the second business evening of ACEN. And for those of us online also, we thank you for finding out time to be part of this business evening.